All right, let's explore a few foundational equivalent statements. This one here in red behind me, P, and not P, double negation. All right, so think about that for a minute. Just thinking about what a double negation is. If my P statement was, I will hunt this weekend, and not P is, I will not hunt this weekend, then not P is, it is not the case that I will not hunt this weekend. Seems like that's probably going to be the same as hunting this weekend, right? So let's test it with the truth table. P is either true or false. Not P is the opposite, false or true. Not P is the opposite of this, which is true or false, which matches the original. So this is the proof that not P is equivalent to just P. And because P is arbitrary, it doesn't have to just be hunting this weekend. P is an arbitrary statement. These are always replaceable. So anytime you have that double negation, it is not true that something does not occur, or it is not true that something does not exist or whatever, then it's the same as just saying, well, it does. Okay? So these are logically equivalent statements. Another example here, I have this combination P and Q. P is I will hunt this weekend. Q is I will shoot a deer this weekend. As I'm filming this, this coming weekend is early antlerless deer season, which I do plan to go hunting. And so this I'm hoping to be true, right? Well, we'll see. So P and Q, I will hunt this weekend and I will shoot a deer this weekend. So I could say either I'm going to go hunt this weekend or I'm not going to shoot a deer. That kind of makes sense. You can't shoot one if I'm not out there. I could also say if I don't hunt this weekend, then I will not shoot a deer this weekend. So there's a couple different statements here. What I'm going to do is use a truth table to prove that these two statements are equivalent, okay, meaning that their truth values at every location are going to be the same. So let's start off with, I want to switch colors here, match up, a little color coordinating. We'll start out with P. Yeah, and we have Q. I should make that look a little nicer. Yeah, close enough. Okay, so P is true, true, false, false. Q is true, false, true, false. I am going to need not P in here at some point. So let's go false, false, true, true. We're going to need not Q at some point. So let's do false, true, false, true. And I'm going to need, let's do P or not Q. All right, so this is a disjunction, so P, not Q. I need them both to be false in order for the or to be false. So that occurs in the third row. So that's false. Everything else will be true as long as one or the other is true. Okay. Then I have not P, if not P, then not Q. All right, and that one, the antecedent, remember, in order for this to be false, the antecedent must be true and the consequent false. Otherwise, it's a true statement. So, I look at not P, I look at not Q. I need true in the first column, false in the second. There's only one place where that occurs, and that's in the third row. So that will be false there. Everything else will be true, true, true. And you can see that both columns have the same truth values, right? True, true, false, true, 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 false, true. And so we would say that these two statements are indeed equivalent. Okay, so So P or not Q is equivalent to not, if not P, then not Q. All right. And there are many other variations of equivalent statements. Some that we're going to see involve conditional statements as well. In fact, there are many statements that are equivalent to conditional statements that are going to be important to us.